little metal parts there. An incandescent light has a filament in it. This is what Thomas Edison invented, right? So the filament actually heats up and lights up and gives off light because of the electricity passing through it. So it's not passing over a gap. It's actually going through the filament, heating it up, and lighting it up. You'll notice that on that, it doesn't matter which direction the electricity is going, so you can flip it back and forth on the battery. Which brings me to another point. So we've kind of discussed, and by the way, slow me down and ask me questions whenever it's a small group. So this is the most fun, actually, because I can stop and whatever and deviate. And I might push you on one course. So we've talked about batteries, we've talked about battery sizes, we've talked about their voltages and how to find them out. And we start talking a bit about diodes and light-emitting diodes and lamps, so the incandescent lamp. So what you'll notice, though, is the LED is quite a bit brighter than the incandescent light. So as folks may realize, these days we're seeing a lot more LED lights, even more so than fluorescent lights, because LED lights are the most efficient. They give out the most light per unit of electricity used. Fluorescent lights work in they work in somewhat of a similar fashion, except the electricity is passing between two electrical points in like a fluorescent tube, and it's exciting a gas inside there. And actually John probably knows this better than I. By the way, if you ever have any electrical questions that you want deep, awesome knowledge, and you have the time to listen to John, because he may go on and on. But John knows, like, he is just a vast, like, repository of knowledge. So anyway, so that's fluorescent lights. They excite a gas. The LEDs, you know, light jumps through 2 points, and I don't have a better description for that. I know there is one, but I just don't have it. And then incandescent lights have a filament. So the reason why I'm demonstrating the LED versus the filament bulb is because it's a great way to start describing the 2 types of electricity. Or, I mean, I guess there's multiple types, but the 2 ways that electricity moves. One is DC, which is known as direct current, and the other is AC. So AC-DC, just like the band. AC is alternating current. AC moves back and forth. So think of like I'm holding a wire up, and the electricity is just shaking back and forth. The electrons are actually shaking back and forth. And then DC, think of the electrons or the electrical charge at least moving in one direction.
What's the difference in terms of its use, or what's the difference?
Yeah, that's a good question. So DC tends to attenuate or lose its power over distance, right? So what ends up happening is, like, if you were to wire a house for DC, you'd have to use really thick copper wires, and it would be really expensive. So a little bit of history on this. It was Tesla who was promoting, what was he promoting? DC or AC? Crap. What, was he DC?
Because Edison won.
Edison won, but the thing is Westinghouse still implemented AC. I'm just trying to figure out. Okay, so I've got to go back and figure that. Hold on. Well, I'll figure it out from John.
So, but on like a AC DC, like I understand that the electrons, how does that get controlled?
Yeah.
I mean, how do we make it